Hello guys, welcome back to another video. Today we are going to see how basic gates are going to work in Proteus and simulation. So let's have a look at how is gates are in working. So we will look at their truth table, their equation and their symbol. First, let's have a look at AND gate. If you see AND gate, this its symbol is D-shaped and its equation is x dot y. When we apply two inputs like x input and its y input, and it will multiply it will see when when both are high, one will be 1. And if you see OR gate, its equation this, and it will add both inputs. So when both are 0, output will be 0, and otherwise output will be 1. If you move further, so in NOT gate, it will simply invert our inputs, and symbols are here. NAND gate is simply opposite of AND gate. If we apply NOT gate on AND gate, it will give you NAND gate. Its output are when both are high, output will be 0, and otherwise output will be 1. Now let's move forward to NOR gate. NOR gate is opposite to OR gate. So in OR gate, when both 0 will be 0 and otherwise 1, and in this case when both inputs are low, then output will be 1, and otherwise output will be 0, like this. In XNOR gate, the truth table is given by, and its equation is here. So in XOR gate, output will be decided by alternate inputs. When we use 0 1, it will give 1, and 1 0 will be 1. And otherwise, when we apply same inputs, it will give 0 as off, like this. And lastly, XNOR gate, it is opposite of XOR gate. Will in this case, when both inputs are same, it will give 1. Let's implement our circuits. And first, this is AND OR, and this is our implementation. So these are these gates which are implemented in Proteus, and these are logic state. These are AND or NAND or NOR, XOR, XNOR, and NOT gates, and it is combined by each other. Likewise, if we see if we run this study and look at this output, which will be shown by LEDs. First we see 0 0 0. Let's check this out. 0 0. This one 0 0. In 0 0, AND gate will give 0 input, which is shown in LED, and as you can see here, AND gate will give 0 as both inputs are 0, and similarly NOT will be 1, NAND will be 1, which is on, and NOR will be on, as well as XNOR. So as you can see, LEDs are shown that these gates are on and others are off. If we use alternate input, then NAND will be 0, as it will give 1 1 2 1, and likewise all these gates. So due to some technical issues, we are back, and this we saw that these inputs, and we apply these inputs, how these gates will work. So if we see at our these gates, uh, when we apply same inputs, like as you can see, and let's have a look at our PCB design. So these are our gates, which is ICs, and all these LEDs resistors are connected here, and we use connectors as in PCB, so we can use our PCB layout. So here is our PCB. We can likewise our components, and we passed up this. Let's move forward for lab 2, which is we will implement all these gates separately. These are 7 gates which we implement, and first we look at so when we apply both one, the AND gate will work and output will be 1, and likewise we will see how OR works. When we apply 0 0, it will 0, and you can see in our LEDs, and when we apply 1 0, it will also 1 0. When we apply 1, and it will 0, it will off when all will be 0, all input will be 0. Similarly, we can see NAND gate, and NAND gate is opposite by AND. So when all these inputs are 0, this output will be 1, otherwise the output will be 0. As you can see in our truth table, NAND gate, when both are 0, both will be 1, output will be 0, otherwise output will be 1. You can see that when we apply alternate and 0 0, it is 0. Let's move forward for NOR gate. NOR gate is opposite of OR gate, and when we apply 0 0, it will give 1, and otherwise it will give 0. You can see 0 0 into 1, otherwise the output will be 0. Now move forward for our XOR gate. In XOR gate, when we apply similar inputs, then when we apply alternate input, this gate will be on, and when we apply similar inputs, it will be 0. Similarly, if we see XNOR gate, it is opposite of XOR gate. When we apply similar inputs, it will on, and otherwise it will be off, as 0 0 into 1 and 1 1 will be 1. So it will 0 0 into, it gives 1, and 1 1 into 1, otherwise it will give 0. So next is NOT gate. In NOT gate, these are when we apply 1 into 0 and 0 into 1. So that was the video, and hope you like this, and subscribe and share this video so everyone will get these input. And lastly, just to clarify that we use ICs as given in lab, 7400, 7404, and similarly so on. Thank you for watching. Keep smiling. Allah Hafiz.